Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, I'm gonna take you through the creations of this what I call the Perlin Rose. It's kind of this kind of design that I make. Um, Basically, this is just a circle going through Perlin nose, but its circles are getting like a different seed of Perlin noise. Currently in Sverchok we don't really have the seed attribute for the noise, as you might already realize. So this if I use vector noise, these nodes still need to grow. It has the scalar and vector options with the input of vertices. This might be okay for depending on what you're doing. It will give you like a result anyway, but in order to make something like this, you need to do a little bit of I don't know. I call it like a trick. Yeah, let's just get started to it with it. Yeah, okay. Vector noise. That's our key node there. You can do this to any kind of mesh, including 3D mesh, but I will do it using circle. So this is the Perlin Rose making of. At least you should get the concept. So I started with a circle. We know that the circle, if we use the viewer draw, will give us circle. Whether it's just points or with edges or with face. We're just gonna do it with edges. So if you plug in the vertices there, you're not gonna get nothing much. This is just a okay. This is circle goes into vector noise. It looks already pretty random, and if you think okay, maybe you use vector math and using multiply scalar and float, what will you get? Okay, you just get like looks like the scaling of the noise. You kind of wish that it does this something like randomized input vertices. This is one node that give you that kind of convenience. Of course, it randomize the circle, but it's doing it in all kind of directions, and you easily end up with something that's looking pretty random. You wish that the vector noise will be more like this with the seed value and more control, but not for now. I guess you need to work it out yourself. If you use something like vector math, let's say you're using the original vertices and then you're attaching this guy into that guy with this guy set to add. Now this one started to look a little bit better. It's kind of pushing it in all directions, and in order to make it like only flat, let's just separate the vector noise into XYZ. Vector in. So we don't want any vertices being pushed in the z-axis, so we zero out the z. Okay, so that seems to work all right. Okay, what's next? We can just join this. What's next? It's gonna be how we can kind of randomize the seed of this noise. Oh, and one thing, you might want to kind of control the strength of the noise. Maybe you want to use the scalar, multiply by scalar here. So float value. So it gets it gets quite involving pretty quick. So this kind of, okay, that gives you a little bit more control, a little bit better. Now if you want to animate the noise, you can use a vector map here and use vector in here, and you can push it in the Z direction or X direction, Y. Actually it's probably better in the Z direction, depends what you want to do. Okay, so we get that happening. What should we do next? We want multiple circles, not just a single circles. How do we do that? You might think, okay, use the matrix in, but in this case, I think we're better off using multiple circles here. Just generate it here instead of doing it in the matrix. So let's use range integer or range float. Use the count, plug this to the radius. Okay, so we have that thing happening already. So that's controlling the smaller circle, that's controlling the larger circle. If we shrink this down, you will see that even though when we do it like this, it looks like its circles are getting a different vector noise, but apparently that's not what's happening. If we shrink this down, if we compare, they are all actually the same. You see, they're moving the same. That means our circle is really, even though it's many circles, it's still the same circles, sort of. It's still the same objects. And if I scale this up, the larger circle are getting less and less noise. That's not what we want, so be careful with that. So how do we fix this? Let's see. You might be able to do this kind of range float and just plug in the start or the stop. This doesn't seem to work, so I think we have to do it in the up here with a frame. So okay, that's one single frame. Let me try math, and here let's add a multiple frame value to pass through all this. Let's use range integer. This is kind of like our seed value. Count 10. So at the moment we have 10. That's our key value. So 10 here and 10 there. Plug this guy in. So supposedly we have now. We still have the same kind of noise happening. The funny thing is, I think if I do this and plug this into the step and shrink this down, we are getting a different value noise for its circles. So that's this is kind of revelation for me the other day. After a couple of tries, this is the one that actually works. If you look at this is 10 circles, each one is getting different kind of noise. So that's where the magic starts to happen, right? This is exactly what we want. Is this guy that's controlling that guy, or maybe actually this one actually controlling it. This one seems to be controlling the number of the circle itself, which is the vertices, the number of vertices. So this guy are pretty related. So that's very interesting, because I believe the answer is when we look at the, okay, it just crashes. Let's reopen Blender. If you look at the data, you will see that things started to make a little bit more sense. Okay, reloading Blender, which happily crashes, and we open it. Okay, we're back. Start on this. This one can control the seed, sort of. Don't worry about that for now. So let's look at it in the stethoscope. This is a single frame number. Okay, and with the add, we are getting multiple numbers. Probably clearer if we're using the viewer text MK2 view. So here we say, okay, we have 20 objects, which is correct. We have 20 objects, but each object has this a different point value for the noise. That means for our circle, we are really we're really gonna have a different vector number, vector noise, and that's exactly what we want there. It's a little bit hard to understand this part. This is like a single value, and it plugs into this vector. So the vector now, this guy, this means like for each of our circle have different points, right? Remember that, and each point get some kind of crazy random noise. So, and the noise is it's gonna be per point basis, and that's why it gets a little bit complex like this, a little bit specific. If you want, you might actually, we are getting like kind of like spike here. Sometimes I think, I have a feeling that this setup is not 100% perfect, but, and because you're getting this spike, and maybe I could in a way randomize something here. Just randomize, please shuffle. I don't know if I need to do this. Yes, so now we're not getting spike anymore. This is I don't know, it's like it's a question mark. Anyhow, we have this working. This one. Where's our time? Okay, this time we need to, maybe we can just multiply it, so we have slower motion, 0.08. So it's smoother. There are still like a lot of corners here. Maybe we can increase the number of vertices, 60. Yep, that's kind of a little bit of random, though. It's suddenly our noise is very random, so maybe list shuffle is not a good idea. Maybe list shift is better. List shift. Plug this in, plug that in. Level 1, level 2. No, I don't think it's a good idea either. Anyway, keep it like this. So we are still getting that. Maybe I need to reduce the noise or something. Maybe do the scalar in here. Maybe doing it up here. Okay, maybe keep it simple for now. Don't worry about that. I still don't like that spike. Oh well, just list random. Don't worry about that, I guess. Maybe we can smooth it somewhere here with the add. So we do another scalar and scale it here. Yeah, that's interesting. I have a feeling that's the noise itself. It's too random. Wait. Oh well, at least it's giving us something. We can actually use matrix in here and do our scaling range float. Use a count and plug in the count into this guy. Create a couple and vector in. This is gonna control the scaling. It's another like a kind of like a global control of the scaling, and then we also can do the location range float, do it in Z, start, stop, count. Okay, so now we have that, and everything's moving in motion, even though there's a spike happening. I have a feeling that it's because the way this circle being pushed, there is not much correlations between these points. What you really want is really just this is the circle, and you want to push in and push out the points in certain directions. If you want to keep it smooth, because I have my own setup, this guy. So with this one, you can see it's pretty smooth. Maybe I can give you a quick look at my setup. So we have that thing's happening, we have this thing. I think the only difference is just this circle and then add. So let's try doing that. Circle and vector math, do an add. This guy and plus this guy equal that guy. So we are still getting the same spikiness, which is a bit weird. standard Perlin. Maybe new Perlin is smoother. No, maybe cell noise. No. Voronoi. Maybe one of them is smoother than the other. That's Voronoi. Standard Perlin. Maybe less. Multiply, add these vertices. Maybe I need to do this scalar and multiply scalar somewhere. Close to the noise. Maybe here. One. Okay, there's a little bit of mystery there. Well, I guess that's something you might want to figure it out yourself. It could be that I'm using a different noise, so I'm doing it in a different way. So anyway, this is, I think, it's a pretty good start if you want to get this kind of design. At this stage, you can also turn it into something different, like that. That's really interesting. That's probably not what you want, but at this point it's like it gets pretty random, too much randomness. Maybe just yeah, that's pretty interesting, although not really what we want. But anyway, that's pretty much it for this live noding. Hopefully this is useful. If you have any comments, feedback, suggestion, let me know down below. I guess this is pretty interesting design, and again, this is kind of the result that you can get. Yeah, I don't know how I create this smoother pattern. Very interesting. Maybe I did something that's slightly different. Yeah, this design actually reminded me of a poster design by Mr. Kazumasa Nagai. He's a Japanese poster designer. I don't know how old he is now, but when I was at the graphic design school, this kind of design reminds me of his work. It's all about minimalistic, but the design looks really intricate and almost like a very thin fabric, and the colors are really subtle. He used a lot of these lines, and I think maybe he used Illustrator for that. These days you can use OpenGL to generate like a generative art, but you can also use Blender, like in this case. I guess the tools help you design all kind of objects. So okay, this is apparently smoother now, which is pretty weird. Where did I do it differently? Maybe here. It's a count. 1. See, this is what I don't quite get. This thing control the noise. That's even more interesting. Like so that value controlling the smoothness, which is super bizarre. And looks like our circles are now looking the same. Might have to yeah, it's a mystery anyway. That's a Sverchok Add-On in Blender. Just play around with it, you will find it. Thanks again for tuning in. I'll see you on the next